Right, so we are going to walk through these problems together so you guys can follow along here, and if you have a calculator close by, you can also use that. And in class, you guys are working through the Pythagorean Theorem, which involves all right triangles and the side lengths. Knowing two side lengths, we can get the third side length. And so Pythagorean Theorem says that a squared plus b squared is equal to c squared, where if we have a right triangle, the hypotenuse is always going to be c, that is the longest side, and the other sides are called the legs, and those would be a and b. And it doesn't matter which one you call a or b as long as c is the hypotenuse. And so in problem number 1, it says a mast is supported by two cables attached to its top and to points on the ground 20 meters from its base. The height of the mast is 30 meters. Calculate the length of each cable. So we are looking for the length of the cable here. So we're looking for this length here, and I suppose we're also looking for this length here, but once we find one, we can find the other. So right now, we're just going to focus on one of these triangles, one of these right triangles here. And so we know that the longest side is the hypotenuse, and that's the cable. So that's what we're trying to find, the cable. And this side here is 30, so that leg, and this leg down here is 20. So it doesn't matter which one you call A or B, but let's just label that A and B. But we are solving for C, the hypotenuse. That's what we don't know. What is C? So using the Pythagorean theorem, A squared plus B squared is equal to C squared. And all right triangles. So that means that we have 900 plus 400 is equal to c squared. 900 plus 400 is 1,300. So 1,300 is equal to c squared. And so to get c, then we have to undo the squaring. To undo squaring, we take the square root. So just like when we're solving equations, addition and subtraction are inverses of each other, opposites of each other. So we undo one with the other. Multiplication and division are inverses of each other. So we undo with those two operations. But with squaring, with an exponent, we need to do the inverse. In this case, taking the square root is the opposite of squaring. So that cancels out the squared term, and we just have c. And so now you're going to need a calculator to do the square root of 1,300. And so that is, on the calculator, approximately 36.1. It's 0.0555 repeating, so if we're rounding to the tens place, it's about 36.1. Okay, so we have a calculator handy. I wonder if I can quick track down my calculator here so you can see that. I'm sure you're using a calculator, but so we're going to do 1,300, and then the square root button is over on the left hand side right here. So if we take the square root of that, there's that 36.0555. So we're rounding to the tens place, we'll say 36.1. Okay. So now, number 2, a gate is strengthened by fixing a strut along each of its diagonals. The gate is 2 meters long and 1.2 meters high. Find the length of each strut. Actually, I think part of the drawing is hidden here. So this should be 1.2 here. See if I can fix that by the time you guys see it. If not, write in 1.2 there. So we're looking at this triangle, and once again, we're trying to find that hypotenuse. We're trying to find this length here, knowing these other two lengths here and here. All right, so we're going to get this right angle. So once again, that long side we're going to call C, that's the hypotenuse, and the other two sides we're going to call A and B, those are the legs. So 1.2 squared plus 2 squared is equal to c squared. And so now we'll go ahead and square 1.2 on our calculator. I wonder if we can do that here. Whoops. Apparently, I clicked on an add. Let's get rid of that. 1.2, the squared button is right here. So 1.2 squared is 1.44. Plus 4, 2 squared is 4, is equal to c squared. So that would be 5.44 is equal to c squared. And now let's go ahead and take the square root of 5.44. 0.44, square root button over here, that's about 2.3, rounding it. All right, so let's do the square root of both sides. So to undo that, we should just be clear that's what we're doing. And so we now have c is approximately, what do we say there? No, I lost track of that. 2.3 meters. And so, by the way, you can just check over here. Notice that 2.3 is longer than both 2 and 1.2. That hypotenuse always has to be longer than the other two legs. Hypotenuse is always the longest side. So that's another thing you can just quick do, and we could do that with number 1 as well. 36.1 is greater than both 30 and 20. So if you get something that's less than the legs for that hypotenuse, then you know you've done something wrong. So you go back and check it out. All right, number 3. Ken takes a shortcut along the path from the gate to the bus stop. Calculate how much further it would have been if he had walked around the edges of the field instead. All right, so we're going to first track down this shortcut here. So it's going to just take this route directly right here, as opposed to going down and then over. So we're going to find that path right there. Once again, we'll do the Pythagorean Theorem. For those a and b, the hypotenuse is always c. So 40 squared plus 80 squared is equal to c squared. 1600 plus 6400 is equal to c squared. So that would be 8000 is equal to c squared. All right, now let's undo squaring by taking the square root on both sides. So that means that we get c by itself. C is equal to approximately square root of 8000. So 8000, square root button, is about 89.4. And I guess that would be meters. Okay, but we're also going to see if that truly answers the question here, because it says calculate how much further it would have been if he had walked around the edges of the field instead. So if he had walked around the edges, that would have been 40 plus 80, or 120 meters around the edge. And we had him go 89.4. So how much further is that? Well, now we can take the difference and see, okay, how much further did he have to walk? So the difference there, 120 minus 89.4, would be 30.6 meters less on the shortcut. So in that case, we had to solve for the hypotenuse, but we also had to apply that and answer the question. Now, in your lessons upcoming, I think you're going to find some problems in which you might be given the hypotenuse and one of the legs, and you have to solve for the other leg. You'll be talking about that in class, so we'll just stop here today with just solving for the hypotenuse, but just be aware that that's going to be the next thing that you guys will be covering.